Are we actually? Yeah. You're supposed to say I'm recording now.
We are recording now.
Hello, everybody.
Hey, everyone. Welcome to our.
Yeah, it's our
Rust review. I think
patch notes.
Yes.
Yeah, patch notes.
I think the last one was like maybe 20 releases ago, maybe 10 releases ago, like a good while, at least a year.
Yeah, like during one of the COVID years, one of the many COVID years ago.
So we live in Denmark now. That's changed.
Yeah, cats haven't changed. Both cats alive.
There's
snoozing.
a cat napping right behind you.
You can't see.
No, that's right.
Lots of people have asked for this to come back. So we're recording again. Thank you to the people who've asked for it to come back.
Yes.
So let's do patch notes 1.63.
Patch notes review, where
Yes.
we go through that for.
Oh, a big hairball.
Oh my gosh. You okay?
Baby cat.
Oh, she woke up from her like little nap
Oh,
with a hairball.
it's okay. It's okay.
Can I show? Oh, she's down there.
No, that's it. She's woken up.
Yes.
It's tough being a cat.
It is.
She seems fine though. She seems fine.
Yeah.
For
She
everybody's
like choked
word.
a little bit. She has that with her hairballs.
It's difficult having like long hair and being a cat, I think. So, hairballs happen. Anyways, back to patch notes.
Yes. So for you today, we have the Rust 163 patch notes, which came out yesterday.
We're so on time. Wow.
I know.
Amazing.
I know.
For once.
So for people who don't know, the format here is we go through the patch notes, we read them out loud, and then we talk about them. And if there's something interesting to say or we want to try something out, we do so. And then usually by the end of the hour-ish, we should have gone through everything, and we hope you enjoy it.
Yeah. Sounds good. Do you want to start us off?
Yes. Sure. All right. The Rust team is happy to announce a new version of Rust 163. It's a programming language that empowers everyone to do reliable and efficient software. Great. You can update it using Rust up. So if you have, I won't read everything it is. Okay. So what's new? 163 stable. Scope threads.
Oh, interesting.
That's Mara's.
Is it Mara's?
Yeah.
Congrats, Mara. That's huge.
Yeah. Do you want to read it?
Sure. Rust code could launch new threads with studs thread spawn since 1.0, but this function bounds its closures with static. Roughly, this means that threads currently must have ownership of any arguments passed into their closure. You can't pass borrow data into a thread. In cases where the threads are expected to exit by the end of the function by being joined, this isn't strictly necessary and can require workarounds like placing the data in an arc. Now with 1.63, the standard library is adding scope threads, which allows spawning a thread, borrowing from a local stack frame. The stud thread scope API provides a necessary guarantee that any spawned threads will have exited prior to itself returning, which allows for safely borrowing data. So here is an example. Okay, so we have a mute a vec of 3 items, and a mute x, which is just a 0.
Yes.
And then we spawn a scope thread.
Yes.
With some println stuff.
Yes.
That debugs the vector that we defined in A. And then another spawn thread, which changes the value of x by incrementing it from values from a vector defined in A. Cool. I want to see what x is. Should we run this?
I mean, we can.
I think it's...
Would you like it?
Yeah, sure. Let's just
Okay.
copy paste this
Great.
into the Rust playground. Just.
Let's see, what version of Rust do we have? 163. Yeah, that's the latest one.
Yes.
wait, this needs a function main. Yeah, that seems about right. It was a bit too big. I think if we do this, it's still legible. Yeah, there we go. So here it prints, what does it print? Prints debug A. Hello from the main thread. Hello from the second scope thread.
And hello from
First
the main
scope.
thread again.
And then here 9. Oh, they did a mix of debug and print line, so the output is like a bit odd because this is the debug output.
Right. Should we just do print?
Print line. Now it should like all go into the standard out. There you go. 1, 2, 3. Yeah.
Oh, interesting. Do you see? Oh no, here first. I was like I thought the first scope thread was the first that printed, and then for some reason the 1, 2, 3 printed at the very end. But I'm incorrect.
Well, the thing here is that line 22 has a fixed ordering because it is guaranteed to run after all this code.
Right.
But the ordering of the spawns within is not guaranteed.
Right.
Right. So hello from main thread prints first, but it doesn't need. Well, does it need to? I think this one does, but the ordering of these two is like random, essentially. Yeah. Do you see what's going on?
I see that we can build out X out of the valley that's actually done outside. So we're borrowing the A in the second thread, right? And we can mutably borrow X in the second thread.
So I want to pull your attention here. Like here we see we're referencing data from outside of the thread. So it's a strict borrow.
Yeah.
Right? Which is kind of cool. But more importantly here is we're doing mutation. So we mutate the value of X. Right? And then we say, hey, actually, the length of X is, or X is now the length of that. Or we can even like say, right? X was 0 at first. Now X is 3.
Can I be cheeky?
Sure, or 4 actually.
What happens if we mutate X in the first thread and the second thread?
Yeah, sure. It's not allowed. I can tell you that much.
Yeah.
Yep.
Yeah. Let's see the error. Let's see the error.
Yeah. So here you go. First mutable borrow, second mutable borrow.
Okay.
You're borrowing same piece of data
twice.
In two separate threads. That's a data race. Rust says no.
Cool. Thank you, Rust.
Yeah. Okay. But that's what this allows you to do. So borrowing over threads. I believe one of the first examples in the Rust book requires you to spawn a bunch of threads. If I'm not mistaken, this will simplify it.
Yeah, I think that is the first thing in the book.
Also, another fun fact. This used to be in the standard lib before 1.0. What
happened?
The way they did it was found to be unsound.
Oh, okay. So this is just for like a re-implementation of the thing?
Yes.
Okay.
Do you know who did the re-implementation, the initial version?
Okay, so it wasn't, well, I guess the initial wasn't Mara. Who did the initial implementation?
Stepan.
Really?
Yeah,
cool.
as part of the Crossbeam library.
Oh, that's cool. Good
so
job, Stefan.
Crossbeam for the longest time has had scope threads, and Mara eventually was like, well, I think Mara took point on that with like, hey, we should like move it into standard lib.
Yeah.
And yeah,
cool.
It's now stable. Finally, after 63 releases, before 1.0, 63 releases later, it's finally here. So
cool, nice,
very cool.
Good job. Do you want to read this one?
Yes. Oh, also, I should mention that Gankra did a bunch of like the theoretical work behind how to do this. I won't go into details of like how it's done, but it has a lot to do with look how std thread scope does not return a value. So thread spawn returns a handle that you can then like, handle.join. But here thread scope is like joined in place. So it can't be moved and, you can't progress past it because it's just in place.
Cool.
And that's sort of the key difference. It used to have a handle, I believe.
Oh, I guess good job to Aria as well.
Yeah, exactly. All right. Rest ownership for raw file descriptors handles IO safety. So this expands, without like reading what this does, this expands like Rust's safety guarantees into OS handles. So handles to like OS types, like files and networking, etc. Which is exciting because it fixes bugs in my code.
Oh, really?
Yeah. Sunfish code.
Nice.
Dan worked on this, which is very cool, together with Josh Triplett, I believe, did a bunch of work on it too.
Cool.
Anyway, okay. Previously, Rust code working with platform APIs, taking raw file descriptors on Unix-style platforms or handles on Windows, would typically work directly with a platform-specific representation of the descriptor. For example, a cint or the alias raw fd. So on Unix platforms, the representation essentially is a number. You have a number and that's it. For Rust bindings to such native APIs, the type system then failed to encode whether the API could take ownership of the file descriptor, e.g. close, or merely borrow it, e.g. dupe. Dupe stands for like duplicate. You can clone it, essentially. Now Rust provides wrapper types such as borrowed FD and owned FD, which are marked as wrapper transparent, meaning that extern C bindings can directly take these types to encode the ownership semantics. See the stabilized API section for the full list of wrapper types stabilized in 163. Currently, they are available on CFG Unix platforms, Windows, and WASI.
And WASI.
Yep.
Interesting.
So,
But I guess makes sense.
WASI is the WebAssembly System Interface, and they care a lot about who owns what. That's part of their model, very strongly so. And I think Dan got into doing this through the WASI world, realizing a bunch of stuff about like descriptors, and then like, hey, I could extend Rust with these things. I think he's like he's a library contributor now as well, which is cool.
Ah, nice.
But yeah, we recommend that new APIs use these types instead of previous type aliases like raw FD. Yes.
So instead of raw FD, use borrow FD and owned FD.
Yes. So something you might like notice here is it doesn't come with an example the way this comes with an example.
Yeah.
Right? But it is a headline item because it is a big deal, but it's kind of subtle and not relevant for everyone.
Right.
But to put myself on the spot here is let me show you
FD lock. Oh my god.
Let me show you a soundness bug in this thing. Right? So FD log takes a operating system level what is it? Advisory log. So you can ignore these logs, but you can opt into respecting these logs. And new function takes type T, like as raw here, which is the as raw FD on Unix, and then on Windows, like we have to do some type shenanigans. On Windows, it takes the as raw handle. Where's that platform? Windows MSVC. No, what does as raw do? Has a as raw handle, like the handle type. Yeah. So it flips Windows CFG, whatever. Anyway, you can put a file in this, and then you say, hey, cool, my file's got like an advisory lock around it, like a mutex.
Right.
But at the operating system level.
Right.
Right? Kind of. That's the idea. But if this file is set to async mode, then we now experience, I believe, undefined behavior.
Right.
Because we can't express that this file needs to be, like I believe we need to take ownership of it. There were like very subtle things. Anyway.
So then you're saying your borrowed FD and the owned FD helps you fix these slight discrepancies?
Yeah, I forget. It's been like a year. This stuff has been like in the works for a year. I remember the exact rules like a while ago, but the TLDR is we have soundness issues because of how I did this. I didn't know when I wrote that. And IO safety will allow us to better express like the requirements. I believe it needs to take like an owned file or something.
Right.
And that will solve it. Damn it, I thought I had the example better in my mind. Anyway, we have an open PR. Dan like made that PR and has like kept it updated. So I've farmed out my knowledge there. But yes. Yeah. We use that type because it, like as raw FD allows you to be abstract over, is it a socket, is it a file, is it a something else? No, I don't care. I just want to like, be able to create a thing around it.
Yeah, and read it. Okay.
Right? And now we can do so safely. This should never have been like a safe function. This should have been unsafe.
Oh, really? Okay.
I did not realize that at the time.
It's interesting how you were allowed to make it safe.
Oh yeah, but it uses unsafe internally, so that's entirely my fault.
All right. Let's back to the change log.
Yes. Anyway, that's my attempt at an example of like where this will be useful. But yeah, this will be a big deal, and the way we will see this be rolled out most likely is a gradual addition to the ecosystem, where APIs like there will be a CFG like, hey, if Rust version 163 or higher, let's add the additional like owned, like borrowed FTE, owned FTE, all these things. And then once it exists in more places of the ecosystem, then crates such as FT lock can switch over to use as their main thing.
Right.
Because if we switch everything over at once, then it won't be
There'll
supported
be
by
a whole
APIs.
bunch of inconsistencies in
And
people's work. Yeah.
Yeah. The thing is, we'll see a like low level crates. We'll see a push out for these things, and it's a big deal. But it's also very subtle, and most people don't need to care about it. But I care, and I hope others will like too. Anyway, yes.
Right. So next item on the list is const mutex, RW lock, and convar initialization. The convar new, mutex new, and RW lock new functions are now callable in const context. That's pretty cool.
Mm-hmm.
That's very cool. Which allows avoiding the use of crates like lazy static for creating global statics with mutex, RW lock, and convar. This builds on the work in 1.62 to enable thinner and faster mutexes on Linux. Nice.
Shall we write a quick example?
Yeah, we should. Should we do one with like a mutex? I think that's the coolest one out of them all.
So we have this. My string. Yeah, there we go. Or was it allowed in const? Wait, hold on.
It was convar.
Wait, does that? I think this is allowed as well, but yeah. So lazy static. I believe statics need to like have const stuff on the right hand side to be initialized. Anyway.
Hold on, does this compile?
Yeah, both compile.
Yeah, both compile. Because it was for const, so you didn't have to do a lazy static for all the mutex initializations. Lazy static, the number of times I've used you.
Yeah, so this is like a big thing, right? I believe this is useful. I forget when this is useful. They say for mutexes. I forget. But yeah, you can now just put a mutex directly in there. Mada on Twitter had an example of this, like in our big release thread.
Yeah.
Which I think was like this.
That's great, and then you can just pass that around.
Yeah, you can mutate it. Which is nice.
Yeah. Yay. Turbofish stuff. You go for it.
All right. Turbofish for generics and functions with Impul trait. So I think Rust 130 something. When I started doing Rust, this was like one of the first editions that they did. Like back in 2018, summer 2018, Impul trait was like added, and some people were like unhappy about it. I think it used to support Turbofish, and then they removed it last minute, or like in a patch fix. I forget how they did it, but Turbofish is now allowed if you use Impul trait.
Nice.
So yeah, for a function like this, you weren't able to specify the trait there. However, this is now allowed. So do we copy this? Yeah, essentially here, function foo takes type t, and you say value t, and then f impl copy. Like, oh wait, hold on. Are we allowed to like specify that? Now I'm curious. I think I just explained the wrong thing because I didn't fully understand it. Okay, so we say foo u32, right?
Yeah.
And then we call it. And then here we say 12 or something, right? This function takes 2 arguments, but 1 argument was supplied. Okay, 12, right? Takes 2 arguments, but u32. All right. So one interesting one is if you then make tj, right? And we say j copy. Functionally, these 2 are the same.
Is that going to compile?
Bar. So if we replace this, no, this will be slightly different. This function takes 2 generic arguments, but 1 argument was provided.
Yeah, because we're only specifying the U32. Can you supply 2?
So in the case of bar, we need to do that. So this is all allowed.
Interesting.
Yes. So we still can't. It seems like, okay, so it seems like the change here is if you have a type T here, then Turbofish was not allowed at all.
To provide it as the
yeah.
type, yeah.
So if you're mixing the 2, but now it is. But it also means that if you have a function foo like this, right? And you use Turbofish, then migrating from Impul trait to a named param, named generic,
yeah,
will break the Turbofish calls.
Right. Okay.
Which I believe is inference, which I believe means it is technically not a breaking change, even though it practically would break code.
Okay.
So I would say the Yosh recommendation is,
oh my God.
or at least like what I'm gonna keep doing is I'm gonna not use Impul trait in my public APIs.
Right.
Like this is Impul trait is not a bad thing. Impul trait makes things like really easy, especially like in return type. You just have to be aware that switching from one to the other, though not technically considered a breaking change, I believe will mess up like some things. So if you have to be consistent anyway, using like the explicit variant, at least for arguments, seems like the safe route to go. Like you can move things around, you can move things to where clauses, no problem. You can, so it's where I'll like lean towards.
I'm wondering, so
Yes.
I've been having this thought, this is sort of unrelated, but does it do coercion? So let's say I define, I'm going to be absolutely shit with your keyboard.
What do you want? Just explain it. I'll do it faster.
So what, no, I type.
Okay. All right.
Let's call this, like, I just want to see if I define this as a I64, and then how do I escape? This is not escape.
Caps. No, just the one button. Just no.
Caps? Okay.
There we go.
And then I use T here. You're not writing. You're here.
There you go.
Will that coerce it to U32? It does. Okay.
No, it doesn't. Look,
Oh, it doesn't.
type T is only used in the left and the first param,
Right,
not the second.
Right.
So T and then 12 here or something, right?
That
then,
would coerce, yeah.
yeah, this doesn't type mismatch,
Yeah.
right?
Okay.
But this also means that we can do that and it will just work,
Right.
right? Because this is inference.
Right. I think that unless it's like specific, like 12 and 12, like it's specific with ints, I usually don't like using the Turbofish syntax. I just like to define it in lines, so then I can go back and see like, oh, T is of this type.
Yeah.
But I'm a very visual person. I kind of need to see things usually.
Yeah. Sometimes you do need Turbofish though.
Yeah, definitely.
That's why, like, if you don't want to think about it, which is me, I don't want to think about it. I don't want to think too much about this. But what I'm reading here is spelling it out like this instead of like Impul type like there.
Well, the thing is, spelling it out is a lot more legible too. In a way.
It depends.
Okay.
I would argue it depends. I don't want to cast judgment. Some people prefer this,
Yeah, fair.
which I'm like, I get it. But like at least here, it's a bit more flexible. If you want to move to a where clause later on, or if you want to extend it, I think this will remain my preference, even though this is now allowed because of the way that this Impul here does not show up as a required param there still. And that's okay.
Right. Cool. Well, we deviated a little bit.
We expanded.
Yeah.
Right.
Okay, cool. So the next thing is non-lexical lifetimes migration complete. As detailed in this blog post, we fully removed the previous lexical borrow checker from Rust C across all editions, fully enabling the non-lexical new version of the borrow checker. Since the borrow checker doesn't affect the output of Rust C, this won't change the behavior of any programs, but it completes a long-running migration started in the initial stabilization of NLL for the 2018 edition to deliver the full benefits of the new borrow checker across all editions of Rust. For most users, this change will bring slightly better diagnostics for some borrow checking errors, but will not otherwise impact which code they can write. And there's like a announcement for non-lexical lifetimes in the 2018 edition.
Yeah. So Nico wrote this post a couple days ago, a week ago, which is like, hey, here's the work that has been done and what will happen in the future. Essentially, it means Rust 2015 now has NLL and compilers going forward no longer have two different borrow checker implementations internally.
Right.
So it's a big deal for the compiler maintainers.
Who don't have to know two borrow checkers at the same time.
Exactly.
Yeah.
It simplifies the compiler, and I would simpler is usually better.
Yeah.
So hopefully people happy. Do we need to expand on what NLL is?
I think that's probably beyond the scope of the patch review, I'm gonna say.
Yeah. The long version, or if I can give like the abridged version.
The very abridged version, okay.
You used to have to do a lot of you would see a lot of code that was like that, and then like
this is the very abridged version.
Yeah.
Very abridged.
Right? Because the borrow checker would need to know that, oh, there's a scope here, you know? So we need to insert it.
Right.
That, and with, what was it? There was like macro use at the top, and then extern crate was like everywhere. This is Rust 2020. When I started doing Rust, it looked like this.
Yeah, I did. Yeah, I also remember that.
I didn't like it.
Extern crate was so confusing.
Yes.
I don't know if you remember.
Oh yeah, extern crate, foo, and then
oh my God.
use foo, and I was like,
no, stop,
right?
erase.
And now it's like, we've removed this. This is gone, that is gone, that is gone. And now it just looks a bit, it's better.
I bet nobody heard us because you were typing so loudly.
Maybe the microphone's good. Who knows? All right.
Oh my God, I really hated the extern crate stuff. I was so confused by that. Anyways, that's not.
Yeah, people some people were like, hey, we need like a package manager, and then there were people like, no, what do you mean? We're systems language, we don't need it. And then a package manager was built, implemented, and everyone was like, holy shit, this is so good. It's like, yeah. Before my time. I've only heard the stories.
There's a bunch of method additions.
Yes.
Array from sounds really useful.
Correct.
That's nice. That's very nice.
Yes. So you can now create a static array from a closure, and you just like run it n times.
That's perfect. Great.
Before this, creating this was like messing around with, I guess you could like do an empty array. So I think the before this was 5 or something, and then .map existed. But now you can just do it like this. And it keeps an index of how far you are. So if you want to do like something like prefill based on index, which is an operation people do, that you can use the index instead of like keeping an external counter or something. This is nice. This is very nice.
Yeah, I like that. Box into pin. That seems useful too.
Converts a box T into a pin box T. If T does not implement unpin, then box will be pinned. Oh, I'm sorry. I started reading it. Is it okay if I?
Yeah, go for it.
All right. I hadn't seen this, but it's relevant to my work. So converts a box T into a pin box T. If T does not implement unpin, then boxed will be pinned in memory and unable to be moved. Good. Where boxed is reference to boxed will be pinned in memory. This conversion does not allocate on the heap and happens in place. Yes, this is also available via from. Good. Constructing and pinning. Okay, what did you want to say?
I wanna figure out how does the compiler. So if T does not implement unpin,
Yes.
right?
Yes.
Then boxed will be pinned in memory and unable to be moved. So I guess the compiler is just going to tell us this can be moved at some point. Like I'm wondering what is the error here if you cannot move? Because you always get a pin out of a box, but if the T doesn't implement unpin, then that box cannot be moved, and therefore when you try to move it, what happens? I want to know the error case scenario.
Oh, it just says can't be moved.
Yeah. That's the thing.
I mean, exactly. But interestingly, so this is pin stuff, and pin stuff is relevant for async code, and I do a lot of async.
Do you?
Really? I've been known to.
Shit.
In the state of California, they issue warnings for that. Constructing and pinning a box with pin into box new can also be written more concisely using box pin. Correct. So this one we've had since forever. 133. Yeah, that's when the future was stabilized, I believe. So you can use box pin to create a new pin box. Oh. This into pin method is useful if you already have a box T or you're constructing a pinned box in a different way with box new.
That seems it's like the dot boxed method. I know that's not on the box itself, but
dot box. Where do you have dot boxed?
Yeah, like you can box like even like a.
Does that have it?
Yeah. It's not on a box, but
I know Futures have the Futures RS library has a box extension.
Oh, maybe that's what I'm thinking about.
I think that's what you may be thinking about.
Because I've definitely used that box and stuff before, but maybe it was on a Future.
Yeah. But that's non-standard.
Yeah, okay. As usual, I'm not good at names.
No, that's fine. It's not recommended that crates add an impul like from box T for pin T, as it'll introduce ambiguity when calling pin from. Demonstration of such a poor impul is shown below. Ooh.
Who? That's not nice language.
No, well. I guess they cast judgment of don't do this, which point taken. Yes. So why is this allowed? Where a static A is the allocator, that's fine. So box T, and you say we're gonna take ownership of the box. Yes. So single ownership of a heap allocated piece of memory, and then we say we
I just poured myself some more water.
Audibly.
Soundtrack.
Help, I'm dating a Foley artist. Please.
I'm so sorry you found out this way.
All right. So we can safely construct a pin out of a box because boxes like heap allocated memory is pinned anyway. So all we're saying is like we take ownership of the pointer into it, and from now on we promise it won't move, and that should be fine. Unless it's unpinned, then you can like do whatever. But yeah, okay, I understand. I understand.
Cool.
Do you have any questions?
No, I understand.
Okay, great.
I was just interested in diagnostics, but
Okay.
that got answered.
All
really
right.
well.
Then I think we can move on.
Yes.
These all look like a set.
They do look like a set. We gotta watch out for time. So you know.
Yeah. I know.
TriReserve tries to reserve capacity for at least additional elements more than the current length. Oh, nice. The allocator may reserve more space to speculatively avoid frequent allocations. After calling TriReserve, capacity will be greater than or equal to self-len, plus additional if it returns okay. It does nothing if the capacity is already sufficient.
So these methods are fallible counterparts to the existing methods in the standard lib, like binary heap reserve here.
Right.
But this one will panic on overflow.
Right, and I guess this doesn't.
This one
returns a result and
returns an error.
Yeah.
Instead of panicking.
Right. Nice.
That's what the try prefix is for.
Cool.
So I believe vec, if we look at TriReserve, vec already has it. Vec TriReserve, string TriReserve, but now binary heap and vec DQ join them.
Yeah, binary heap, vec DQ, and something else. There's three.
String.
No. Binary heap, OS string, and path buff.
That's right.
So vec DQ already had it. Probably the implementation was the same as for vec.
Yes. Path try exists. This is on path. Oh. Wait. What does exist do?
So this returns a result as well, which...
As opposed to exist method, this one does not silently ignore errors unrelated to the path not existing. Okay.
Okay, so this just returns all the errors, any possible errors, but exists...
Returns a bool.
Yeah.
And this one returns a result of bool.
Okay.
All right.
Seems good.
Seems useful. Filter map. RefFilterMap. So std-cell RefFilterMap.
Makes a new ref for an optional component of the borrowed data. The original guard is returned as an error if the closure returns none. The ref cell is already immutably borrowed, so this cannot fail. This is an associated function that needs to be used as RefFilterMap. A method would interfere with methods of the same name on the contents of a ref cell used through dref. Okay.
Okay. So it creates a new ref for an optional component of the borrowed data.
Yeah, and the borrowed data is the original, so the first argument.
So here we see RefFilterMap B1.
So that's the borrowed data. That's the vec that we borrow, okay.
v1.get, and then this returns a result refu32. Get one. Oh, there. Oh, fascinating.
So it creates a new ref cell from the borrowed data that you borrow, but the other one doesn't. Obviously, it does not get mutated. Or anything
so it's like a sub borrow on a ref cell, almost.
Yeah.
Look.
Okay.
Look,
Yeah.
Look.
Yeah.
Here we have a ref of vec u32. Right. Here we have a ref of u32.
Yeah.
Instead of having a vec, we just narrowed it down to a single element.
Yeah, because you wanted to filter map, right? So you want the one.
But we did a But the idea is instead of like borrowing the whole thing, we now borrow a
just
part of the thing.
Okay.
Yeah.
I guess this is useful if you're like dealing with a really large set of data, also.
Probably.
Yeah.
But yeah, I think of it as a sub borrow. It doesn't do. It still borrows the whole thing, right? Conceptually, it's still a ref over the whole thing. But the data contained within is a subset of the original data, even if the lifetime is still the whole thing. Cool. That's right. Ref mute, filter map, same deal. But mutably.
Yeah.
These two, only one of them they're mutexes. But okay. NoSlice tlen. returns the length of a non-null raw slice. Great. Cool. Do you know the non-null APIs?
I've never worked with non-null, no.
Then you're doing it right.
I don't know. No, I'm not gonna ask why would you use non-null. That seems like
it's pointer stuff. It's FFI stuff. It's like the interact with like low level bits on the computer thing.
Yeah, I think Rowan uses non-null somewhere.
Probably
under the hood. Thankfully, I don't have to deal with it.
Exactly. So here, this allows you to get the length of a slice. It seems of a non-null raw slice. Cool if you need it.
To owned clone into uses borrow data to replace own data, usually by cloning. This is a borrow generalized version of clone from. Seems nice, yeah. I would want to use that.
Hello.clone into. Right. So this allows you to reuse allocations is what it does. Right? Here we have an existing string, and then we say, actually what we're going to do is we're going to place this data in this existing allocation.
Yeah.
Right? So if we run this, it doesn't concat, I believe. So,
I mean, you can try and see.
Yeah. So from hi. Right? It replaces the...
Yeah, okay. That seems useful too.
But it will reuse allocations, which is good.
What will happen if, let's say, initially you allocated like a very small amount, and then when you clone into, you have like a fuck off giant amount that you're cloning into? Is it just going to reallocate?
Yes.
Well, then.
It always does.
Okay. Well, then you were still reallocating anyways afterwards, but.
Yes.
Yeah.
IPv6 adder to IPv4 mapped.
You want me to read this?
Yeah, I was reading.
Yeah.
No, it's okay.
Converts this address to an IPv4 address if it's an IPv4 mapped address as defined in the RFC 4291. Otherwise, returns none. So colon FFFFF ABCD becomes ABCD. All addresses not starting with FFFF will return none.
I never knew that IPv4 addresses could be mapped into IPv6 space. But that's cool. That means that IPv6 feels like a superset of IPv4.
Clearly, you have not read the IETF RFC 4291 section 25552. Otherwise, you would have known this.
As if you have.
No, not particularly this one.
No.
I'm more of an HTTP spec kind of gal.
Are you? Name all of them. All right.
A bunch of Unix stuff.
So this is all the owned FD stuff.
Yeah.
Right? So we can look at it like as FD instead of like as raw FD. We now have as FD, which is a safe operation.
Nice.
Right? So file open can now be represented as a,
as an FD.
Yeah, which returns a borrowed file descriptor, always.
Nice.
And then I believe there's an as owned FD.
Yeah, owned FD. Probably.
Yeah, owned FD, but is there... No, there's no as owned.
Let's try the IO own FD, see what that does. No. As raw FD.
Nope, that's the old one. Right. So you can always go from, if you have an owned file descriptor, you can get the raw file descriptor out of it.
Yeah. Okay.
But that's like not, you should not be doing that.
Then maybe perhaps we need an as owned FD as well. Or maybe that's not possible also.
I assume there's reasons why it's not there.
Okay.
I may not understand them yet, but it's not for lack of people having thought about it.
I'm sure it's not people not having thought about it.
Yes.
Socket as well.
Yeah.
Also borrowed socket. I guess that's also related to that.
So here's the tables in case people are like curious.
Oh, I love when there's a table. That's always very handy for
on
me.
Unix, there's file descriptors, and everything's a file descriptor. Most everything's a file descriptor. Right. In Windows, there are handles and there are sockets. Some things are handles, like files. Some things are sockets, like TCP stream. Right? So there's not a neat single thing mapping, but there's different ones, and they promise different things. Anyway,
Cool.
So, oh wait, hold on. I did like this little table here, Unix.io, where they describe it as like raw FD is like a void pointer, or I forget what these are called. This is like an anything pointer, like any type, essentially. Pointer to anything. Borrowed of the is like a reference. And owned of the
is a box. Interesting.
Yes. Okay. So the item itself doesn't live inside of your thing. Like a box lives on the heap, not on the stack, right?
Right.
So it's somewhere else, and you have a handle to that something else. Owned of the says that something else is a system resource, and we just have a handle to it. Right? Or like it still lives somewhere else, even though we own it. Which I think is interesting. Anyway.
And a bunch of thread stuff. Oh, sorry.
You okay?
Yeah.
Okay, great.
A bunch of thread stuff as well.
Thread scope and thread capital scope and scope join handle. Here's the same example.
Yeah, that's the one we've done. I'm going to be so confused between thread scope and thread capital scope.
So one's the function you call.
No, I know.
And the other one's the type.
I know, but I just...
So the capital scope is the closure here. The type S is the scope object you spawn on.
The type, and the S is the of type scope. Yes.
Correct.
And just when they're side by side, it's just like, oh god.
Yeah, and scope join handle is scoped join handle and owned permission to join on scope thread. Blocks and termination. Oh, T thread ID. Okay, and you can join it here. So you can spawn on a subscope, but still like join that thread. That's allowed. Cool.
Nice.
These things are now const. Any interesting ones?
Well, the ones we talked about, the mutex, convar, and rw log.
Yes.
From UTF 8 for string.
That's
also nice.
That is nice. Well, string size.
Sorry, yeah.
Cool. All right. That seems neat. All right. I think we just about rounded out here. Or do we want to check out what... This is the Rust release. Check out what happened in Rust. What happened in Rust? Well, here's the full list of all the changes. Link attributes checked more strictly. Prepare Rust for LVM opaque pointers. Cool. I don't know what this is, but better IR integration? Seems good. Oh yeah, we have support for Nintendo 3DS.
What?
Yeah.
Okay, that should have been in the main release notes. It's like bragging rights for Rust.
I believe it's tier 3.
Nice.
Jam1 Garner did the work on this on Twitter.
Cool. So who is writing Rust on Nintendo?
Jam1 Garner.
Yeah.
What else we got? Impul termination for infallible and make the result impulse of terminate. What? I need to read this more. Impul termination for infallible and make the result. Okay. Well, that's some big brain stuff. I really don't want to like try and make sense of that right now. Stabilize the bundle native library modifier. Oh, we can compile to Apple Watch.
Cool.
I believe is they
So
were
Nintendo, Apple Watch, all in one release. Great.
yeah. At Apple, actually, what tier is this now? Tier 3. Great.
Three. Okay.
Cool. I believe the M1 Mac is tier 2 because we
Okay.
don't have CI for M1 Macs.
Well, join the lineup of millions of other places who don't have CI for Apple.
Hopefully soon though.
We all hope.
Yeah.
We're all there. We're all hoping.
So in that sense, it's not too weird that we don't have like watchOS we don't have watchOS CI, so we can't like get to tier 1 and tier 2. We just added it, so it's like it starts at tier 3. Maybe it'll move up to tier 2 at some point. I don't know the exact thing. Yeah, the rest of these things, they're kind of nice. No. They want to look at cargo briefly. Anything interesting?
That's
-- config CLI option.
what's that one for?
Purdis FCP. Someone should.
Config path.
It would be nice if we had stabilization reports for this as well.
You gonna read through all of these comments?
No, I'm trying to see if someone wrote a report of like, this is what this thing is.
Oh, like even like an output of config.
To pass config options to any command. Okay,
Interesting.
you can pass config options to any command now. The cargo package Rust version environment variable is now set when compiling a crate if the manifest has the Rust version field set.
Ah, okay.
All right.
That's neat too. I guess you can change it up and compile it through different versions also as you go, which is nice. It's nice to toggle if you want to toggle it really quickly.
Yeah. Interesting. Trying to see if there's anything else fixed. Yeah, well, that's last time. Cargo add was added last time, which is nice. That's all the next release.
Seems good.
Yeah, nothing major. Otherwise, there's a new one. Clippy.
Lots of new lens. Oh, that's a lot of new lens.
Large include file. I assume if your include file is too large, this will not be happy. Cast apps to unsigned.
Error expect.
Yeah. What does actually this do? Checks for .error.expect on a result type. Okay. Oops. Empty struct with brackets. Oh, that's a style thing, isn't it?
Oh.
All right.
You use a lot of the ones with brackets.
Yeah, I do. I prefer it.
Okay.
It makes it more consistent. Bytes count the len. Await holding invalid type. Await holding invalid type. What's that?
That's not the correct.
This one. Allows user to configure types which should not be held across the await suspension point. Oh, they made this a clippy lint.
You can specify the type name.
I see. Yeah. So this says this should not be held across an await point. This says suspicious. Okay. But you can configure which ones to do.
Which clippy lens do you mean? Or?
Which types to flag for. But it's only based on like name, like a simple name substitution.
Interesting.
Yeah, okay. Well, fair enough. But also, something else is going on that this is trying to help with.
I don't use that.
No, it's okay. Pupuse. Restricts the usage of pupuse.
Oh, so when you have two nested.
And that. Oh, right. Because the mod is not pub. It's like. This also is internal filter. I don't. This may actually like mess with a lot of code, though, right?
Update and find out.
Well, it should not be enabled by default. I hope. Like there's a built-in one which may conflict with this. Anyway.
There's a bunch of stuff with drops as well. Empty drop, drop, non-drop. Forget non-drop.
Clippulent. Checks for empty drop implementations.
Okay.
All right. Fair. Submem drop. Does nothing. Oh yeah. Submem forget X. So this doesn't implement drop, so forgetting it does nothing. Has no side effects. All right. Cool. Well, I think that's then just about it.
Yeah.
Yeah.
That was a full hour of reviewing patch notes.
Yes, we did well. We hit the hour mark.
I know. Usually we're like an hour and a half in. And
yeah. Actually, how long do we do? 55 minutes.
55 minutes. Yeah.
Not too bad.
Nice.
Hope y'all learned some Rust today.
Yeah. Hope you enjoyed this too.
Any fun Rust facts too? Oh yeah, this should check out your talk when it goes live.
Yeah, but it'll be like another month.
Oh really?
Yeah.
Oh okay.
September.
Okay. Great. Yeah.
I did a talk. It is not live yet, therefore.
You're just recapping the last like 3 sentences.
Well, I don't know. What if people are confused? Anyways, that's it.
Talk at RustConf,
yeah.
which was last week. Yura did a great talk. Me as a partner, very supportive of the talk. Yeah. Do you have anything? I have nothing.
Our cats are cute, so you know.
Let the world know.
Yeah.
All right.
Well, thanks for tuning in.
No, truly, we mean it. Thank you so much. Like, oh my God.